Hello again, higher algebra students, here with our final lesson of Unit 2, which is solving complex power equations with a calculator. Um, there are going to be some questions that will have some values that will be a little more difficult to deal with without a calculator. So we'll talk about the calculator piece a little bit, and we'll go from there. So um, our agenda on a regular day here in class will be the homework questions, and then we'll go through these notes and get a little work time. But the main thing is to be able to use your calculator to solve these complex power equations. So just to recap our kind of progression through this unit, we started off with just having essentially the same base and um, exponents that one was a variable and one was an actual value, so that we had x equals 5 right out of the gate. Then we started to have a different base, and so we had to rewrite this as 7 squared to the x plus 5. And so we ended up using a power to a power rule, distributed, and this was 7 to the first here, and started to solve for x that way. Then we had 2 that needed to be simplified down to an exponent, and so we needed to find a common base for these, and in this case it was 7 squared to the x and 7 cubed to the x plus 2. And so we had to go power to a power rule with both, or utilize power to a power rule with both. So we had 2x in this case and 3x plus 6 on the other side, and began to work from there. Okay. Then we started to deal with fractional exponents. And so we looked at the idea of, for instance, if you square and then cube root, that's the same as just raising it to the 2/3 power. Then we took those fractional exponents and put values in with them and started to break that up. So we took 2/3 and said, okay, let's make it 8 to the 1/3 first so that we can cube root the 8 so we get a little easier value. And then we'll square after that to get up to our answer of 4. So that allowed us to use fractional roots and actually solve without needing a calculator in that situation. And then we looked at when x was in the base and did this same sort of thing, and solved for x here by using things like reciprocal roots. So we raised both sides to the 2/3. And so, or in this case, we had to convert it to 2x to the 2/3 equals 8. And then we used reciprocal roots, and we just had a 2x there. So there was a little more work at the end where we had to divide our value by 2 at the very end. And then finally, we ended with scenarios where we actually had a little more complicated bases. So in this case, on the bottom left here, we use the reciprocal root idea. And what that did is it took care of the reciprocal root. So we had x plus 2 equals 4. So we still had some solving to do at the end again. Kind of like up in this one, it's just we didn't have a value added or subtracted. And then finally, we get to a problem like this where we have to deal with this 2 and 4 first. So we had to subtract the 4 first from both sides. So that gave us the 2x minus 5 raised to the 3/2 equals 16. And then we had to divide by 2 on both sides. So then let's see if it'll let me move. There we go. So then we had the x minus 5 finally alone with the base with its exponent. We divided by the 2 here, so that gave us 8. Now we use the reciprocal, kind of like we did up in that problem. So this was a whole progression here of dealing with x's alone, x's, or I should say x's originally as exponents, with numerical values as bases, and then we got to x's as bases with numerical values as exponents, and so on. So it was quite the progression here through these exponents. Now we're going to just use the calculator a little bit more. So it's largely the same types of problems, but now the values aren't going to work out quite as cleanly. And to use the calculator, this button here that's highlighted is really the most important for you, which is the caret under the clear on the graphing calculator. And this allows us to bring in exponents. And again, if it's a fractional exponent, that's fine. Then you just put the caret and put 3 divided by 2 up there, for instance. If it was actually not an x, let's say it was 8 raised to the 3/2. It allows you to just write that fraction in there, or in certain cases, you could convert it to a decimal if it's a a rational decimal, so you could write this as 8 to the 1.5. That would be fine. And so we'll look at just a couple examples of this here, and then we'll talk in person a little more about the calculator as well. So what we're going to do is similar to what we have been doing. We're going to isolate that rational root. We'll write the problem using rational roots, and then use the reciprocal and simplify and solve. So kind of like we were doing at the end of that progression a couple of slides ago, where we just isolate the x plus 5 raised to the 3 halves or whatever it happens to be. So we look at these questions here to get us started. You can see right out of the gate that we have a 15.2. This is different than what we've looked at in the past. So the first thing I'm going to do is I'm going to add the 8 to both sides so that we can start to isolate this root over here. And I'm also going to convert this to, instead of being raised to the 4th and then a cube root, I'll just write it as x plus 5 raised to the 4th and a cube root as one fraction. So it's really raised to the 4/3. And this is 23.2 on the right side. Okay, now we need to, again, use that reciprocal. So what we're going to do is we're going to take this whole value on the left and raise it to the 3/4. And again, what's done onto one side must be done onto the other. So on the left side, the 4/3 and the 3/4, again, the reason they take care of each other, because when you multiply the fractions, 4/3 times 3/4, because it's power to a power in this case, is 12 over 12, and 12 over 12, of course, is just 1. So this is just x plus 5 raised to the 1. But again, you don't need to write it like that. You can just write it as x plus 5 equals. Now, this is where the calculator comes into play. I have no idea off the top of my head what 23.2 raised to the 3/4 is. So I'm going to go to my calculator, take 23.2, and I'm just going to raise it to the 0.75. I'm just going to convert that to a decimal. Again, because it's a rational decimal, it doesn't go on forever. It's not 0.33333333 or anything like that. So that ends up being not equal to, but approximately equal to 10.57. I'm going to go 2 decimal places each time. And so that value, it's irrational. The decimals go on forever. It's actually, according to my calculator, 10.57099795. You do not need to write all of that. Subtract the 5 at the end. And so I have an answer here of x is approximately 5.57. So if you put 5.57 back in for x, you add the 5, that gives you the 10.57, raise that to the 4th, take the cube root, subtract 8, you will end up at 15.2. Second one here, similar sort of deal. I'm going to, in this case, you do need to note that this is a 4. This is multiplied by 4. It's not a 4th root. Okay, the 4 is not up here. It's out in front. So I'm going to divide both sides by 4 first. And again, what I have then on this side on the left is x minus 3. It's raised to the 5th, and it's just a square root. So it's actually raised to the 5/2. Again, a square root, so with no value here, then it's just a square root. It's not a cube root or a 4th root or anything like that. And then 29 divided by 4. Again, this is something that's a little easier if you want to do that without a calculator, but it's still not a a simple answer in this case of being something like 28 divided by 4 to get an integer, a whole number there of 7. So now that I've got my rational roots here on the left side, I'm going to bracket those off and take the reciprocal. So instead of 5 halves, it's now 2/5. What's done onto one side must be done onto the other. As we had on the last example, a 2/5 and a 5 halves, there's an intentional reason we went to the 2/5 there, because 5/2 times 2/5 is simply 10/10, which is 1. So this is just x minus 3 on the left side. And then the right side is 7.25 raised to the 2 divided by 5, or 0.4. You could do either one. And that's, again, not equal to, but approximately equal to 2.21. So it's 2.2086922226. But I'm going to round it to the nearest hundredth again. And then I finally will add the 3. So my answer is x is approximately 5.3. 2, 1. Again, very difficult to do that without a calculator, particularly in this step right there. But you can use the calculator then to help you out. Okay, a couple more examples here. Here we have one that doesn't have any root at all, but we do have the 2 and the -7 there to get rid of first, and so I'm going to add the 7 to both sides. Again, we'll undo, it's kind of reverse order of operations. We'll undo the addition and subtraction first, and then worry about the division and multiplication. And so that gives us a 2x minus 4 to the 5th equals 30. The 23 plus 7, because what was done onto the left side must be done onto the right. Now I can divide both sides by 2. So I have x minus 4 to the 5th equals 15. Now, keep in mind that to the 5th is the same as being to the 5 over 1. So I'm going to bracket this and put the reciprocal, which would be 1 over 5. And with the 1 over 5, then that's taken care of. I'm going to move it over to the right side over here. So I have now x minus 4 equals 15 to the 1/5. Again, no reason you should know that off the top of your head. And again, I keep writing equals, but it's actually approximately equal to 1.72. Again, it's an irrational decimal here, so it's we're just rounding to that nearest hundredth. And now I'm going to add the 4 to both sides. And so I have an x is approximately equal to 5.72. There would be, again, my value. I could put that 5.72 back up into the equation if I wanted to, just to make sure that this equation still worked out. Last one here, jumping down to the bottom. Again, no addition or subtraction to worry about this time. So the first thing we're going to worry about is dividing by 3. So on the left side, that gives me an x minus 1, again, dividing by 3 on both sides, x minus 1 to the 3/4 equals, now 20 divided by 3, if you take that, will actually give you 6 2/3, or 6.6 repeating. So I can write 6.6 repeating like this and still keep the equal sign because I'm not technically rounding anything yet. But I may need to round here shortly, but I'll just leave it as is for right now. So I bracket, now that I have my rational root, I multiply by the reciprocal of the, I shouldn't say I multiply, I raise that to the reciprocal of the previous exponent. So I'd be raising both sides to the 4/3 then. 3/4 and 4/3 just ends up being 1. So I get x minus 1 on the left side. And I now have 6.6 repeating raised to the 4/3, which 4/3 is 1.3 repeating. So you have to be careful here. I'm actually going to leave my answer that I had and just not retype 6.6 repeating, but just do a caret from there. So it actually will end up looking like this on my calculator. So it's answer to, you could also write in parentheses, or type in 20 divided by 3 in parentheses, raised to the 4/3. Either way would work. And again, I keep writing this equal sign here. I'm going to put an approximately equal to. So that raised to the 4/3. Let's see, so we have 20 divided by 3 raised to the 4/3 is approximately 12.55. And then finally, I'm going to add the 1 to both sides. So I have x is approximately 13.55. Again, very difficult without a calculator in this case. But there's our answer of 13.55. And again, we can put that back into the equation if we wanted to check it. That is it. If you have any questions, as always, please ask. The calculator piece is something, if you don't have a graphing calculator, there are some online versions of graphing calculators. There's, in my updates, there's a graphing calculator that I put in one of my original updates on Schoology where you can get one. But that's, again, the calculator would be very handy here, as these are very difficult, nearly impossible to do without a calculator and or some sort of tool to actually do that calculation for you. Thank you for listening. As always, if you have questions, please ask.